What if you could step inside a video and explore it from any angle?
With Gaussian Splatting, you can basically capture whatever you want. It comes with a number of challenges. No standard format exists, no codecs, no infrastructure, nothing.
Our rig is actually very, very unique. This is ultimately because of the unlimited angles that you can later view in VR as well.
This is a real volumetric performance captured, processed, and played with photorealistic results that you can experience as if you were really there. In today's episodes, we go deep with two of the pioneers shaping the future of immersive 4D media. Lennard Wolff, former senior technical director at Synthesia and now the CEO of AdventuryXR, a London-based startup revolutionizing corporate learning through photorealistic immersive experiences.
We don't want to make any sacrifices to resolution. That's been very much from the onset. We were like, if we're going to do this, we're going to try and do the best possible.
And Georgii Vysotskii, the co-founder and CEO of Gracia.ai, a deep tech company specializing in the visualization and distribution of Gaussian Splatting with a focus on VR. They have joined forces to reveal the behind-the-scene reality of building on the bleeding edge of volumetric capture and the future of immersive content.
Processing also really dependent on the way the capturing is done. That's why I would never commit to a particular project without getting somehow involved into capturing right at the moment.
We'll cover everything from the capture rigs and rendering pipelines.
So we have 78 cameras within our rig and around just under 300 lights. We can capture up to 300 terabytes of data in a 30-minute capture session.
To the real challenges of compression, streaming, and what comes next.
For Gracia, XR devices remain the major focus at the moment. The file size of a volumetric video currently starts from 1.5 gigabytes per minute, which is really close to streaming, but it's still not there.
But before we get into it, I wanted to remind you that if you don't have the time to watch the full interview and want to learn from other founders and creatives at the intersection between XR and AI, you should definitely check out the XR AI Spotlight newsletter. By subscribing, you will get weekly interviews like this directly in your inbox and access to a list of tools and apps that allow you to experience Gaussian Splatting in VR on Quest and Vision Pro. Just check the first link in the show description. So let's dive into the conversation and explore what happens when Gaussian Splatting goes 4D. Guys, it is a real pleasure to have you here.
Likewise. Thank you.
Yeah. Thanks, Gabriel. It's good to see you again.
So there has been, over the last months, a lot happening overall in Gaussian Splatting, but even when we are talking about 4DGS, this dynamic Gaussian Splatting. So maybe, Georgii, I would like to start with you. What are these 4DGS and how do they differ from standard volumetric capture? And at the end, why does that matter?
Yes, absolutely. As a quick recap, so we produce volumetric videos based on Gaussian Splatting technology. It basically means that you can render a video from any viewpoint at any moment of time, right after you produce it. And Gaussian Splatting is just another way, another technology to produce those volumetric videos. And volumetric videos have been here for a while, right? For I think already 10 years now. And prior technologies mostly was meshes. All right, and it was mesh-based reconstruction, and Gaussian Splatting is just another way to do the 3D reconstruction I was seeing. The opportunity Gaussian Splatting opens are mostly about photorealism, right? So with meshes, you struggle to reconstruct here. Overall reconstruction of people was quite challenging and required a lot of efforts on capturing side, as well as had a lot of restrictions like polarized lighting, like uniform lighting conditions. You couldn't capture semi-transparent surfaces, couldn't capture shiny surfaces or reflective surfaces. And with Gaussian Splatting, you can basically capture whatever you want, right? Even a glass of water can be reconstructed properly with Gaussian Splatting because of the different way of an approach to 3D reconstruction. Instead of making polygons, Gaussian Splatting basically helps you to reconstruct scene with let's say 500,000 points. Each point has a Gaussian function of transparency, color. Depending on the angle, you look at this point, right? and obviously it has coordinate, right? And this allows you to capture the light behavior inside of the scene, and as a result, work with semi-transparent surfaces, reflective surfaces, free-floating hair, asymmetric lighting conditions, etc. Simply because it kind of the models, its AI approach, obviously, it remember it in its weights how the light behaves in the scene.
So I want to ask Lennard about how to capture those, but I do have a point first. So that is true for any static Gaussian splatting. What happens when we add another dimension, being time? What kind of complexity is that added on top? And in terms of advantages, of course, but also maybe some limitations.
I think the good comparison would be just regular image and a movie, right? So they're in some sense similar, right? The same technologies, but now the picture is moving, right? And it comes with a number of challenges. The first one is compression, because like obviously volumetric video, like Gaussian splatting is a new technology. As a result, it results in a new file format, and no standard format exists, no codecs, no infrastructure, nothing. That's actually what we build at Gracia. And first challenge is how to make those volumetric video consumer ready in terms of size of the file. You need to make a codec, come up with a codec, how you store the difference between the frames, not all frames separately. Netflix doesn't store each frame like separately, obviously. And the second one is how to make them temporally stable. How to make them render smoothly, and how you ensure smooth playback, I would say. And the third one is how you can go from a sequence of frames to kind of things. It's already more comprehensive, I would say, like slow motion, bullet times, and the industry of like 2D production came to it later. So with Gaussian splatting, it's also a challenge. How do you ensure kind of flexible frame rate on the rendering of volumetric video?
That's great. So, Lennard, at AdventuryXR, you are specializing in capturing this 4D GS. Can you explain us a bit what's the process? What's the rig? What are the requirements?
So, I mean, there's different approaches, even than what we are used to with photogrammetry, basically. I think when we first built the rig, it wasn't meant for 4D GS. So there's like a lot of steps that we took for sort of adjusting, and that's been a lot of partnership work as well in sort of modifying the rig to sort of, it's like trial and testing and seeing how that can be achieved with, working together with Gracia as well. But in essence, it's the key differences in the capture process are, first of all, that we have more novel viewpoints. So when I talk about novel viewpoints, it's basically like different camera positions, right? Where traditionally we have sort of a bit like in bullet time, where you have like a line of cameras, and then you have another line of cameras, and then you have another line of cameras, and they all have to overlap by around 70% to get traditional photogrammetry, right? But for Gaussian splatting, we discovered that like the details are everything, and you have to capture as much different angles and as many different sort of positional angles, especially. So I'm talking about like from the bottom, like more up, and all these kind of things. And it was definitely interesting for us because it's actually kind of a nicer way to capture, right? Because you see more, you get more angles, and this is the limit. This is ultimately because of the unlimited angles that you can later view in VR as well, right? Because traditionally in photogrammetry, you wouldn't, it wasn't possible to watch it in VR.
And I suppose it comes also at a cost, having those extra camera. Like, what is also the cost?
So we have 78 cameras within our rig, and around just under 300 lights. So our rig is actually very, very unique, and it's not completely unique, but it's like works on a different principle than some of the other rigs that we are seeing doing this kind of Gaussian splatting. We work on we use multi-flashes. So we get very little motion blur, basically. We have almost no motion blur. And this works very well together with also extremely high frame rates, which we record at. So we discovered higher frame rates, which traditionally we don't do so much in photogrammetry because of the data load and everything. actually give us such a greater result in 4DGS as well. That's again another sort of adjustment that we've made to capturing. But yeah, I mean, it's a fantastic way to capture. And actually, to be honest, for us, it's been very, we're always making new updates. We're always changing things around in the rig. But ultimately, we can see that every time we sort of recapture, we kind of see the step forward as well within the technology. Because I can see that the 4DGS is making everything, more viable, and you get more out of it, basically.
So I suppose this happens in a studio, right? Where you get an actor or a performer, whoever it is. Is that the only way? Like, in a sense, is there flexibility there? So I can imagine that if you want to have a full 360 around a scene, then yes, you need the full coverage. What about something where maybe you want to have 180? Is that something that you've ever considered? Are there something where you can just put camera somewhere and have something that is simpler at a lower resolution? I mean, what are the spans of possibilities when it comes to capturing?
I think for us, like we don't want to make any sacrifices to resolution. I think that's been like very much from the onset. We were like, if we're going to do this, we're going to try and do the best possible. And, and luckily we have a very great, the CTO of our company, it's worked very hard to build a very good compression pipeline for us as well. So like the data loads are manageable, but that's ultimately what it's all about, data load, right? How much data do we capture? In a single day, we can capture up to like 300 terabytes of data in a 30-minute capture session. So how do you deal with that? And if you know that only 180 degrees of the rig will be used later in the final video, then of course, we will cut down and say, okay, we only use that. But for most of our use cases, we've I think playing with the fact that you can be in 360 to be all around and to inspect from all angles, it's kind of the most powerful experience. But it largely depends on the content.
I would jump here and add that we believe that 360 use cases, there are many of them, and it's definitely one of the great things about Gaussian Splatting. But we think that the future of capturing this content is definitely portable rigs, and together with Lennard, as we partnered with AdventuryXR. So, and we now experimenting and already built a prototype of the rig which can be portable, leveraging the same cameras, right? And in this case, you can capture 180, you can capture 90 degrees viewpoint element. Definitely, you need less cameras, right? And I can as a ballpark, I would say 15 cameras would be enough to capture something like 90 degrees of viewpoint freedom, whether you don't expect user to walk around behind your back, etc. So just for couch VR experience, where you only sit in a certain place and just you can rotate your head, you can go even less with the number of cameras. So it's not only about skill, building those portable rigs. It's not about scalability of content production, right? But because not all the content can be captured in the studio, right? Let's say sports, you have to capture it on site, or music, some music events, you need to capture it on the stage. But it's also about kind of democratization of content production, right? So that you will require less cameras, and as a result, you will get content cheaper.
So let's imagine you've got these terabytes, hundreds of terabytes of data, right? How do you process and play this 4DGS? Because that's one of the focus of Gracia.ai, right? So it's the ability to play it, not on a screen, of course, but in an immersive environment, right? Either mixed reality, virtual reality. But how do you process and play it? What are the challenges associated with that?
Yes, sure. So as Lennard mentioned, the amount of raw footage is enormous, right? So, and we really appreciate that AdventuryXR made it to compress it, I think, 35 times to AV1 and AVIF, depending on is it a video container or a sequence of images, and it helps us to get footage to the cloud at reasonable size, let's say per minute of footage, lossless, right? So, and it's the first step for us to obtain the footage from those cameras, right? And it's still 2D footage. Then we've built already a cloud-based processing infrastructure, and it's automated. And we have kind of an internal software that we provide to our partner studios, and so that when Lennard uploaded it, let's say, he can register a data set in our orchestrator, as we call it, and process it like through the whole pipeline, right? Applying the LUTs, cleaning up. By cleaning up, I mean cropping the volume you would like to leave, removing the floaters in a semi-automated way, etc. And you end up with consumer-ready file, a volumetric video, right? And as I mentioned, there is no standard format, and we would love to be one day. And we end up with a proprietary file format for this volumetric video. And this is something that we or Lennard delivers to client, right? But we also need to deliver it along with an SDK, with a viewer that enables professional creators to work with it. And there are two types of plugins. First one that renders in on device, and for Gracia, like XR devices remain like the major focus at the moment. So we have Unity integration, Unreal integration is also coming soon. It makes it possible for creator to compose it with his Unity project or her Unity project and render it on device in Unity XR application. Obviously, we support 2D devices like smartphones, desktops, etc. Another one, and we feel more and more demand actually for it, is from VFX and creative industries such like Hollywood, etc. Right? We cannot share much about those projects because they are under strict NDA, but we have a lot of demand for integrations with professional video editing toolkits, and we now almost have completed Unreal. It's going to be there in like 1 or 2 weeks. So you already can export this proprietary format to Unreal, compose it with your Unreal environment, like or Unity, as I said, and create crazy 2D fly-throughs.
So, Lennard, I was also curious, like when you look at the process of capturing these scenes, right? Either the actors, of course, you need to have the rig, but it's not just that. You need to, let's say, the actors, there has to be a specific setup. There needs to be, let's say, trained in a way, or I imagine, as well as these are still not things that can last 4 or 5 minutes of capturing, right? So, as if my understanding currently, there is a limitation to the length of these scenes, let's say. Can you guide us a bit through the process of that capture and see what are the limitations and things that you can share with people to maybe help them?
Yeah, I mean, from the capture perspective, actually, it's most of the limitation lies around like the size of your rig, right? Because it's like, you can only capture whatever the capturable volume is, basically. Like that's defined by the focal length, the focal distance, and the depth of field, and all these things, right? Like there's a lot of factors that basically play into everything. And like the way that I always look at it, it's a little bit like traditional photography. You think about the exposure triangle, which is the sort of first thing that everyone learns about when they do a bit of photography, and you discover that you change one parameter, like you add more light, and then you can stop down the exposure and different things. And there's always, knock-on effects. Whatever you do, there's a knock-on effect. And the ultimate solution seems always to be add more light. And but then eventually you get to the point where the actor standing in the center of the volume is standing there and they cannot hold their eyes open anymore because it's so bright. So it takes a lot of fine tuning, but I think we're very happy with the capturable volume, which is somewhere around this sort of 2 meter mark, which we found is actually quite manageable for us, right? When it comes to actually capturing the talent, it's a little bit like stage acting. If I don't know, stage acting is very much, you don't have a single viewpoint that you have to direct towards. You're directing towards an audience, so it's always like it's a bit like being on stage on a TED talk or on on something similar. You're presenting, and so for some people it comes very naturally. But for other people, we work with them together. We have a lot of experience with this now, as prior to this we did data sets and this sort of thing. So we've seen hundreds of people come through this kind of capture process, and it's always fun to get the most out of a person. But it's basically like teaching someone to be public speaker.
So I'm also curious because length is a thing that people are really, it's a limitation, right? You mentioned being the data size. So maybe a question to both of you, like how did you come up with the right length? In the sense, like how did you decide, okay, we should go for, not sure, whatever it is, 15 seconds, 10 seconds, 20, 30, not sure. How did you come up with that agreement?
If I'll start on this one. I think one of the great things is actually, with our capture rig, we're not 100% limited to capturing to 5-6. It gets a little bit the cameras get a bit unhappy because the temperature rises and like this kind of thing, because obviously at that point the fans have been off for 6 minutes and the rig is getting hot. But you can do it, right? You can capture for 6-7 minutes if you like. But what we realize is, well, first of all, the Gaussian splatting is very loopable, right? People love seeing like a repetition, or like you can rewatch, and the scene is much more powerful if it lasts around 2-3 minutes, or 1 minute even. It's about attention, right? You have so much attention to this thing in front of you, and there's so much happening, and there's so much to inspect. You don't need 6-7 minutes of it. I think the 1-2 minute mark is the sweet spot, because it means that the person who's delivered what they want has delivered it efficiently. I think that's ultimately it.
You made a very good point. Now, I think that really, really depends on the user that we are going to do. So maybe before moving into users, because I know you guys are focusing on a specific use case for now, Georgii, do you want to add anything else to that when it comes to length?
Yeah, I can add first to the previous point regarding the volume, capturing volume. So since we are working a lot with Adventure, and we are both based in London, so I'm based in London as well. So we now can capture like extremely small, how do they call it, Lennard? I can't remember. Like
circuit boards and like soldering.
Yeah, soldering of micro scheme, right? And it's like it's extremely challenging, but it's possible to capture. So you can reduce this volume to super focused, as well as potentially you can capture even like 5 meter to 5 meter, let's say UFC octagon, right? So in terms of the scale of what can be captured, it's absolutely flexible. We are not talking about like capturing football pitch at the moment. Of course, it's then like a few years ahead from now. It requires a lot of experiments, but from the technological perspective, it's absolutely possible. It's only engineering challenges, how to deal with this amount of data, how to synchronize those cameras, etc. As for the lens, on our side, there is no limitation on the length of the video we can play back. But since the file size, the file size of a volumetric video currently starts from 1.5 gigabytes per minute, which is really close to streaming, and we find it very consumer ready already, right? But it's still not there, so you can have a one-button experience. So you play back, and you can watch without downloading the file up front. So at the moment, we are limited to that user has to download the file up front. That's why we usually publish our technical demos as like 1-2 minutes long, and the content that we usually produce is about like 5-7 minutes long, the same ballpark. So we are now talking about definitely minutes, and the only limitation we have at the moment is compression. How much more we can compress it further, so we unlock like use cases like filmmaking, right? So you can have a whole movie. But I fully agree with Lennard that the nature of volumetric content is that you can watch it from all the angles. So it definitely makes sense to watch it a few times, because the same scene looks different depending on the angle, right? And if you take, I don't know, some educational content, which usually we like, if we capture something, it's focused on 3D, right? It definitely makes sense to see how it looks from this perspective and from this perspective. So the same like 3 minutes, you're gonna loop and watch like 3-4 times. And we see it when we see how people interact with our tech demos, right? We definitely see that people watch, like the length of the session is much longer than the length of the content itself, right? So you watch it multiple times.
So we have discussed a little bit about the technicalities behind it, right? But at the end, it has to be something that provides some form of value to our audience and to our user. So you guys at AdventuryXR, what did you decide to focus on and why?
Yeah, so for us, the focus has been corporate learning. And I think this is largely due to our background, as the four people within our company are all vaguely related to corporate learning in the past. So Michael and Kirsten, who are my co-founders, we basically worked in corporate learning prior to starting around 2012. They started this sort of thing, and we realized that producing this content and seeing this content in action as well, having worked for a corporation, it's ineffective and it's boring and it's terrible and it needs an overhaul, right? But one of the key points about corporate learning is that it is kind of like evergreen content, right? And this is very important for volumetric at the moment, I think, and for the Gaussian splatting as well, is that the content needs to be something, like we said, replayable, right? It needs to be something that is exciting and can be short, but can also be like over and over usable and exciting. And I think that corporate learning has so much where you can develop that it's certainly better to focus on something like that at the moment.
And can you explain us what do you exactly mean by corporate learning? Because people might interpret it in different ways, right? What is it?
So corporate, like the niche of corporate learning that we're kind of targeting is seeing manual instructions, right? Like how to do stuff, right? Like there's a lot of money that companies spend on, teaching. High value employees are teaching people how to do things, right, within a company. But what if you had to only capture that person one time, and they instruct and they show you how to do something, and then you can repeat that like extremely positive learning experience that some person had to previously give to a person by giving them it in a digital form. And I think it's kind of like that idea that you can sort of save your employees' time from having to be used for training, but more so that you have a repeatable experience, right? It's very hard for in-person training to be perfectly repeatable, right?
Yes. And so, I mean, having a volumetric video is just a volumetric Gaussian splatting is just one step of it, in a sense that how do you embed this kind of thing into something that can be deployed to a workforce, can be experienced? I mean, how does it all look? Also, because when we think about this, it's not VR training, but when we think about some sort of like experience that teaches something, there are usually, for example, voiceover, there are steps, there are highlight, there are, I mean, it gets like more complicated than that. Can you share an example of how this type of content can be actually deployed, or you envision it to be deployed?
So obviously we're still working on it, and this is kind of where we're heading towards at the moment. We're with our first examples, and I'm sure that we'll share these within this or around this. We took a specific effort to try and showcase how someone can teach something specifically, right? And we can see that when we add to this, right, what we would add to it is certain AI features, right? I think because we come from the Synthesia background, we started working with Synthesia. We very much think that like GenAI very much fits into all of this, right? The content that is like needing to be like the explanation, these kind of things, the multiple languages and all these things are very, very important to learning videos nowadays. And I think that can come from GenAI, but I don't think that the personal side, right, the teaching side should come from GenAI. I think that's the part where Gaussian splatting does the thing that we love about it the most. It's a real experience, right? You are really in the room with that person, and you're really being explained and you're really being shown. And I think that's kind of like, once you've experienced it, it's the most fantastical thing about it.
And Georgii, you have though mentioned several times, right? For example, like UFC fight and other example of that. Now, of course, corporate learning is one. You have mentioned other example, not at the scale of a football field, but yet something where there are already, I think, hundreds of camera. I'm not sure that is the exact number, but it is pretty close to that, I can imagine. So how about maybe how have you thought about scaling this maybe to fashion or to sports? What are the steps required?
Yeah. With fashion, actually, we have a fashion demo that was captured together in London with quite famous fashion brand. I really appreciate them getting involved into it. And But like our target use case, so we're 2 years in this project by now, and what we finally like, and your vision always evolutionizes, right? And like at the moment, we think that the targeted applications, and it's kind of a structure, so please pay attention. So you have 2D applications that I mentioned, VFX, including filmmaking, advertising, so everywhere, or like sport, immersive repeats, where you would like to basically render a 2D video back from it, right? So this 2D use case stands alone a bit, and we like Hollywood probably stands out because we feel now a lot of demand from this segment. If it's if we talk about XR, like volumetric video rendered real time, so when user interacts with it in a volumetric way and walks around and chooses the camera, like the viewpoint position, we have 2 segments, entertainment and education. On the entertainment side, you have music videos and shows. It's probably the biggest segment. Amaze VR, Soapbox are good examples of the companies who already do it in a volumetric way based on previous technologies and like other technologies. The second one would be fashion. It's I really like this idea because like the dresses looks just fascinating in VR, and you can be on a runway show. Actually, it's a great use case for sure. Fashion, and the third one would be VR filmmaking, I would say, and sports. Absolutely, sports I just already covered, right? So sports in a way that like you capture it on site already, and you as a user can be inside of the fight with the fighter, inside of the octagon, walking around them, or having in mixed reality, having them in your living room. I always focus on XR, but you can also do it on 2D device. On the education side, biggest segment for us is medical education. Already the industry exists. 3D modeling of human body doesn't really makes it work, I think. So we really believe that Gaussian splatting, like specifically volumetric videos here, can really be a breakthrough for this industry, because now you can be in an operation room with a surgeon and watch it from all the angles, and you only you need to record this particular complex surgery only once, right? And now you can watch it. And but we are not limiting ourselves to surgery, right? You also have, let's say, education for students who need to prepare for their exams, so you can see the person and understand their symptoms and make a suggestion of diagnosis, right? And so it's medical education. And the second one, as we call it, observational learning, where I would explain it on an example of yoga and fitness, let's say, right? We used to go to a gym, and I still go to a gym like 3 times a week, to see how and the instructor shows you how to do something, right? And you basically repeat after him. It's called observational learning. When you need a person to show you some complex technique, and you watch it in a 3D in real life, and you understand how it's done, and you repeat, right? And in 2D, it's really tough to challenge. And in this bucket of observational learning, we have yoga and fitness, probably biggest example. Second one would be martial arts. That's I'm particularly bullish about, because and it's a good first step into the sports, starting from education for sports, because it can be pre-recorded. And let's say we have a demo of a professional MMA fighter explains how to do a particular punch, right? And the whole your body involved, right? Your knees are involved, your feet are involved, your everything is involved, right? Both of your hands, like you rotate your body, you have the momentum, and it's just impossible to understand it in 2D, right? And in VR, you can finally walk around him and understand what he does specifically. And I'm not saying that these observational learning, like sports and like fitness and yoga, will replace us from going to a gym, let's say. Or I think it goes on top, right? It's about learning a particular skill, like mastering a particular skill on top of your regular, like going to a gym. Yeah, so these are our target use cases in a quite complex structure, as I said.
Or maybe you were saying on top and seeing, or maybe getting a lesson from someone that you would never be able to afford or even meet, right? That is the other thing. So there's like unlocking those opportunity, of course.
It's definitely all about like recording once and showing it many times for many people, for sure, because the content production is like quite expensive, right? It's reasonable, but it is professional-oriented content production. It requires professionals to be involved, a number of cameras, etc., processing in the cloud, etc. So it only works for use cases where you have many users watch the same content many times.
I think also with fashion, to be honest, it's a similar thing, right? It's a matter of accessibility. Like fashion runway shows, it's one of the most exclusive things that you can do, and like luckily for us, like we can imitate this very realistically because we we didn't build it, we inserted a omnidirectional treadmill into our rig, right? So you expand this space indefinitely, right? So a person can walk however far they want in VR space, because obviously it's not real.
This is a detail that you omitted, and that's a very interesting thing. So basically, in the middle of the rig, there is this infinite treadmill, right?
Yeah.
And does it work on multiple axes, or is just like a straight one?
It can go in 360. You can walk forwards, preferably. Backwards is still a little bit dangerous, but but yeah, it's very like it's a very easy way of expanding this volume that you're recording in, right? It's the sort of secret way.
So I always also like to ask a bit of a business question in some way. So in a sense, how does this work? So there is this a client, right? Imagine someone who says, okay, we would like to deploy something this on the ground. And we have this technology and infrastructure provided by Gracia, and then all the expertise from AdventuryXR about capturing and the whole rig thing. How does these, at least three, usually tends to be more, but how does these three parties kind of like work together to make sure that a client gets what he wants? Lennard, maybe you can start.
Yeah, I mean, luckily we're blessed with Georgii being very collaborative, and we really enjoy collaborating together. And actually, most of the time, it's a case of how can we figure this out together? How can we make our lives easier? What can we do on the capture side to make reconstruction easier? And what can reconstruction make? How can reconstruction make our lives easier? But when it physically comes to, okay, how do we deploy something? How do we build something that's fit for purpose? It really depends on what specifically it is that we are capturing. I think when we talk about the portable solution, which I think is kind of what we're getting towards, right? It's very much a case of how do we build a portable rig that kind of fits all needs, right? Because you don't want to be completely reconstructing, rebuilding the rig every time from scratch, right? Because that would be very inefficient from a business point of view.
Yeah, and sorry, before Georgii, I want to hear your point, but there is one point that kind of like I've been thinking, and here maybe it's a bit like due also maybe to my ignorance, but let me ask it anyway. So, can you, for example, in the future, think about a way where there are, for example, less camera, but use, for example, GenAI to fill in the holes? Is that something that is potentially realistic based on some use cases? How does that work?
I mean, I can start from my opinion, right? This is why. So the quality that we can achieve right now, right, is why we're excited about it, right? We can say, okay, well, at this quality, we can achieve a lot and we can do a great deal. The future of capturing things in this way will for sure change. I think the technology has finally caught up to the capturing process, right? This capturing process is old, like Georgii said, it's 10 years old, but finally we can see it in a real way, right? But where does the next step land? Well, it's for sure, less cameras, less huge dome and rig that you need. It's a matter of like years maybe, that until we are at a point where maybe 6 iPhones in a circle, or eventually one, right? This is not completely impossible. I think the other thing that's worth talking about, maybe from a technological point of view, I think the fusion and the way that it works, and seeing that you can generate multiple angles from the fusion already, depending on like your data set or something like that, it's very possible that this is the future. But what I think is very, very important to remember at the moment is that it's all about realism, right? What we can do with GenAI is create something that is half reality, half real, right? Half unreal. And we saw it like, you look at some of the, I can mention it anyway, but like you look at something like Aber Voyage, right, where they use people and then they use like unreal people to try and like morph them into these younger versions of themselves, right? It's fantastic. It's a great concept. But when you want to capture something authentic, you need to capture it for real at the moment. And to get this level of outputs at the moment, when you want it that real, you need to capture it with lots of cameras and a difficult to build rig. But that's part of the fun as well, I think, because of the reward you get from it.
So, Georgii, do you want to add anything else?
Yes.
On this point?
As for GenAI and how it's gonna affect it, yeah, for sure. GenAI, like the intuition behind it, the following, right? At the moment, you cannot do GenAI of 3D photorealistic content simply because you don't have a data set to train your model on, right? You can generate quite photorealistic 2D content, right? You have a bunch of videos that you can train your models on. You just don't have enough data sets captured from all the angles in order to train one, right? So we are accumulating those data sets, right? Capturing more and more, we're accumulating those. So we, at some point, can come up with a model that kind of helps you to fill the gaps, right? And it's going to be an evolution, right? So it's not 78 cameras next day, it's one camera, right? It's like 78 cameras now, and it's still like it's like Lennard has like enormous rig, right? Enormous in a good way, right? So like it looks super futuristic, right? 50 cameras might be enough. Like you can go low, and at some point you end up like with 6 iPhones and later one, yeah. But in order to get there, you need to accumulate the data and train models that can help you to fill the gaps. The first step that we already do is, for example, sometimes when you capture it from all the angles, you do not cameras capturing directly from bottom to top, right? So you can see some artifacts on your neck or on your chin, right? And we can already use diffusion models to fill those gaps, right? So it already helps a bit, right? So we do not do it all the time. We do not do it for the angles that can be captured with real cameras, right? But it already in the pipeline, right? So it's already implemented as a first step. So it's my vision on kind of evolution of the capturing of these volumetric videos based on Gaussian Splatting. So it's all about the data set and that you need to obtain first in order to make it possible. As for the projects when client comes, yeah, we think that like it is the only strategy that we find reasonable to kick off the whole industry of production, right? And the strategy is that you need to control the whole process, capturing, processing, and rendering. So each step should be aware of one another, right? So our rendering benefits from all optimizations we implement during the processing of footage. They are connected. That's why our rendering is compatible with our proprietary format, and it gets perfect results, renders real time on standalone Quest 3 and other standalone devices. But processing also really dependent on the way the capturing is done. That's why I would never commit to a particular project without getting somehow involved into capturing right at the moment, right? So when we need to capture those soldering techniques, right? I come to Lennard and we discuss how we can make it captured in order that we can process it, right? So we think that it's definitely kind of a good strategy to control the whole content production pipeline because it's new, and in order to crack it and deliver like compelling results, you need to do all three things. And you cannot do all of them yourself. So that's why everyone does what he's good at, right? So and so if a client comes to Adventury, they consult with us how we can make it process and deliver. If client comes to us, we go to Adventury and we ask, hey guys, can you process, how we can capture it, how we can make it happen, right? And portable rigs is definitely something that basically, with portable rigs, it's not that important that it's portable. Not only this is important, right? It's not enough. It also should be flexible in a way that so you can easily reposition the cameras between the takes, because the construction of the camera positions to capturing, let's say, two fighters fighting and one yoga instructor on the floor is completely different. and you want a rig to be not one size fits all, but rather one rig that can be fitted to anything, right? So it's all about, like, we call it internally Dr. Octavius, that it's kind of flexible arms that you can reposition easily, right? But at the same time, it should be solid enough so that you don't have, it doesn't shake, right? So, and we really believe this flexible and portable rig will unlock capturing cheaper and capturing more content per studio day, per capturing day.
I think
So
if I may, just one second. I think also with the portable rig, one of the things that you have to bear in mind, right, is that the larger a rig gets, right, it's a silly mathematical thing, but like if the lowest cameras, right, which are at ground level or like slightly below ground level, are pointing up at 10 degrees to remain the same angle when they are 6 meters apart, the whole platform has to be higher, right? Or like the whole, so the way that a rig expands not only expands the, you know, the sort of diameter of the capture volume, but actually expands the height of the capture rig inversely, right? Like it's so you are expanding at the flexibility that you need to have when you create this kind of portable rig, and you want it to be that flexible, is there's a lot of factors that play into that, basically.
So now, what if we don't need a rig? In a sense, right? Synthetic 4DGS, it's another thing. In a sense that, so let's imagine, just to make it clear for people maybe listening, you have a game scene from one of the best game ever, The Last of Us, right? There is this virtual environment, and we can only experience it from our desk, for example, so, or from our couch. What if you could actually capture that and create that synthetic 4DGS? So not from an actor being captured, but rather from a virtual environment or a Blender scene, right? Now we're talking about video games, but it could be. Do you envision that being, let's say, also some part of the content pipeline due to the reduced, let's say, production cost? Is that a real thing, or I'm just envisioning in the future something impossible?
It is a real thing. It is a real thing, and we can do it already today. We've done some experiments with converting the Blender scene for real estate, like an apartment, to Gaussian splatting. But I don't like fully understand the purpose of it, right? So we sometimes have those requests, but I don't really understand why, right? The only thing I can explain is that, let's say you have a video game back in the days that was not done for VR, and now you can be inside of the video game that was not like that was built for a desktop, let's say, and now you can be inside of it in VR. Quite a niche applications for funds. We can definitely do that. It's super straightforward, and no capturing is required. You, as a creator, you just, if you have access, you just create like these virtual cameras in Unreal, if you have access to the project itself, right? So you can definitely make it. And we on the Gracia platform, like originally we started as a like community platform where community shared their static scenes, and we had many uploads of PLY files of static splatting scenes for video games, right? So the people were just recording their screen, walking around I don't know, a room in a video game, and now they can wear a headset and be inside of the room like they are inside of the video game. It's cool, right? But I see it as a really good feature rather than a use case that can be commercialized. At least I hope to be wrong. So if you have one, please come to us, and we can do that. It's easy.
Yeah,
But,
and this is an example. So I mean, if you have valid use cases, please share it, post in the comments, because that's another thing, right? People want things, but then say, why do you want it? Well, because it's cool. Okay, maybe come when you have something reasonable, like something to build. Lennard.
Yeah, I mean, there's definitely less my expert field, I'll be honest, but you know, the advantage, right? I mean, think about it a little bit from the perspective of photogrammetry. I'll turn it a little bit towards that, right? We have like metahumans in 3D and this kind of thing, right? Like artificially generated or tracked or armed people that you can do, and the quality of those was fantastic, really great considering, you know, how complex this is. But then compared to traditional photogrammetry, I think came in a little bit below that, right? Because it was looking very, like, at times bad. You had a lot of like artifacts. The meshes didn't properly align and all these things. And so the real capture looked worse than the sort of artificial capture. But now with Gaussian splatting, I think it's turned the tides again, where you're like, okay, well, if we can capture real people doing real things, then it makes more sense. So I think it's a little bit the difference between mocap and volcap, right? It's like both exist and both are fantastic industries. But I think to be honest, like, whatever is the best and whatever looks the best is going to have the more greater application. I think that's kind of the way that I see it, to be honest.
I have one last question, because nowadays the 3D industry is kind of like shaken up a bit by these world models, right? Where everything is kind of like generated in real time. So we're talking about this interactive video experiences where you kind of like walk in the space, where it's generated frame by frame by an AI model that was either trained on hours of playthrough. We have seen Quake, we have seen Minecraft, and more. Now, is real time for DGS like pure fiction, or you think a possible distant future?
Yeah, it's definitely not a pure fiction, but by real time, I wouldn't mean interactive, right? So interacting with a character that you captured, so Gaussian splatting at the moment is not very good with animating with them, right? So it's not the best use case to animate them, right? You can do relighting, you can apply LUTs, you can do some stuff. For example, if you would like to put them back on a LED wall behind you as a like background characters for a movie, yes, definitely you can adjust them to fit into the whole color scheme of your Unreal project, let's say, or a LED wall. But it's definitely not a case where you have a person, I don't know, fighting, and now you make a prompt like make him dance, and he starts to dance, right? It's not close yet at all, right? And I would say that the moment we get there, it's basically the moment where we can just do GenAI of Gaussian splatting, right? But what I would say real-time, more feasible use case is that real-time events get broadcasted in real time. I mean, like we now have rendering real time. That's why we use this term for real time rendering on the device. So you can walk around and you don't have any delay, right? But I mean that the event itself, the UFC fight, that I understand that everyone get bored with this UFC fight. It's like I use it as an example.
But it's a good example.
Yeah, good example. Yeah. So I really want to like, you know, how affirmation, right? Affirmation. We will make.
It's gonna happen. It's gonna happen, Georgi. It will.
Gonna happen one time. Yeah, one day. Yeah. So you have a UFC fight, and now you, in real time, can be in the event, right? With a delay for streaming comparable with the broadcasting delay, right? So, and it's super important for sports, right? Because it's like you never watch the football game next day, right? You only watch highlight. This is more feasible. And at least from technological perspective, is absolutely possible. From the engineering perspective, it's a challenge how to handle this amount of data you obtain from the cameras, raw footage. You need to set up probably GPUs on site instead of transferring it to the cloud. So it's an engineering challenge, but it's possible to be done in the next like 1 or 2 years, as we see.
I will say the same. I think from my perspective, like the most real time and most purpose solution is to have something like broadcast, I think, or streaming, whichever is preferable. But like from a technical point of view, like from a camera and rig point of view, it's already possible to send live signal via all the cameras. And I mean, we see this already. Originally, it's actually kind of where volumetric started, so we're almost back to the beginning again. From American football, I think they use it a lot, where they have like bullet time at the finish, at the touchdown. I think they used to have this, where they'd have like 100 broadcast cameras, and then you fly through. But of course, the bigger challenge is how do you add that into XR? I think that's probably Georgi's biggest challenge. I think from a capture point of view, it's actually totally feasible. even today. Yeah.
So capturing is solved for it. Distribution is solved because size of the file is already close to streamable. It's like it's 30-50% more compression and you can stream it, right? But how to make processing of the footage, so converting from 2D footage to 4DJS on the go, it can be done only if you have a bunch of GPUs on site where you capture the content. So you avoid transferring footage back and forth.
Exactly.
So, I mean, to experience this firsthand, the thing I can suggest is, of course, everybody to go on the MetaQuest store and check out the Gracia app that already allows to play, pause, and get this 3D experience. And guys, it was a real pleasure. I have personally learned a lot. I'm sure that people have as well. Lennard, Georgii, thank you very much for being with us today. Thank you very much for listening in. If you like the show, remember to leave a rating on Spotify, Apple Podcasts, or a thumbs up on YouTube. It really helps me keep doing this and shine the spotlights on the greatest founders and makers, pushing the boundaries of XR and AI. Also, make sure to check out the show page xraispotlight.com, where you can find more conversation like this one. Till next time.